All right, so today we're talking about Venn diagrams, and these don't overlap, so you can't have a Venn diagram. Can't be a freshman and a sophomore at the same time. Now, if you want to get technical, you can always have an exception to everything. I mean, there's night and there's day, but isn't there kind of something in between? It's kind of like, well, is it night yet? Because it's kind of getting dark. Is it still daytime? So there's often overlap, and that's what we're going to be dealing with mostly today. Things that are technically mutually exclusive is like if you flip a coin, you're either going to get heads or you're going to get tails. But again, I can talk about the exception. In a really, really rare case, the coin will balance on edge. Now, it's really, really rare, but it does happen. Especially if a nickel. I've ever noticed that the nickels are really wide and they have a flat edge, so easier for a nickel to do that than anything else. All right. Here's a Venn diagram, and it's talking about A and B, and A and B together. Mr. John Venn is the guy who created the diagram. They didn't exist before he made them in 1881, so he gets credit, and that's why we still call them Venn diagrams. All right, I want to actually make one. I think you'll understand it the best if we make one together. Except it's use real data for your class. Except I really didn't like how iPod worked because too many people had. I changed it to music playing device, and pretty much everybody had one. So I'm going to actually be specific on iPod this time, like the old school iPod, not an iPhone, an iPod. So some of you aren't going to have them, and that's good because I want some in the neither category down here. All right. How many of you have an iPod but not a dog? So you're going to go right here. Raise your hand if you have an iPod in your personal one. It doesn't have to be with you right now, but you don't have a dog. Okay, 1, 2, 3, 4, yes?
What if it's just like super old?
That's okay. Still, do you have one or not is the question. All right? So I got 5 people that have that. How about you have an iPod and you have a dog? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Thank you. You have a dog, but not an iPod. 1. You have neither a dog nor an iPod. No dog, no iPod. All right, 2 people. All right, cool. So now what we could do is take this and add them all up. That's 17, 18, 19, 20, 25. There are 25 of you in here today. And now I can figure out probabilities for each thing. It's really easy. You just take the 5 and you divide it by 25 and you put your probability in here. So 5 out of 25 is like 1 out of 5, which would be 20%. So I can actually do that one in my head. 0.20, etc. A probability Venn we don't use as often, but they're nice to know about. I'm just going to finish this one up. 17 out of 25. Would somebody grab a calculator and figure out what 17 divided by 25 is? You need a calculator for later anyways. Yes. 64.64. Next one is that 1 dog out of 25. What is 1 out of 25? I think it's 0.04. Is that right? Because I was going 1 out of 25 would be like 4 out of 100, and that'd be 0.04, right? And the last one's the neither. That's 2, should be twice as much as the 4, so 0.08. I can do that in my head, yay. Okay, so that is a probability Venn because it's got probabilities in there instead of people. This is technically called a frequency Venn because it's how frequent was it that somebody had this or this or this. All right, so there's a couple kinds of Venn diagrams. They're pretty easy to make. Next part is to actually use one. If we had, actually, let's go back to that one I had before. I'd like to know what's the probability if I picked a random one of you guys that I would get somebody who has a dog. Probability that the person would have a dog. Was the 17 and the 1, should I use the 1 or the 17? Both is the correct answer. Because if I asked these people, do you have a dog or not, they would say yes, wouldn't they? And if I asked these people, do you have a dog or not, they'd say yes. So therefore I use all of them and I'd say 18 out of 25. The point is, a really common mistake question is, answer, is if I say, what's the probability of an iPod? And people will say 5 out of 28. These do have iPods, but so do these. All right. Now, here's the difference between and or. It's the last thing you really have to understand. If I do probability of a dog and an iPod, doesn't that sound like it'd be a bigger answer? Dogs and iPods? because it sounds like both of them together. But if I say, do you guys have a dog and an iPod? What would these people say? No, they don't qualify. The only people who qualify would be these people. So and is actually a smaller answer than or. On or, a lot of people think, well, if this one's and, then or must be these two, this or this. But let me ask you this. If I ask these people, do you have a dog or an iPod? Wouldn't they say yes? Yeah. So or is actually all of them. When you say or, I've tried to focus on this a lot so far in probability. When you say or, that means add them up. Okay, so if I say I win if I have somebody who has an iPod or a dog, I'm going to increase my chances. I add them all up. So or is all of them, and is only the overlap. All right, to see if you really got that, I'm going to make you a new one. Let's see, something that's fairly common, and then that's something that's fairly rare. Let's say, do you have an SUV at your house? And then something that's more rare, a fish tank, like you have, like goldfish and stuff. Okay? So who would be, you have an SUV in your family. Raise your hand if that was your family. You got an SUV. Oh, how about this? Just an SUV, not fish. Just an SUV, but no fish. 1, 2, 3, 4, 5, 6, 7, 8, 9. How about you got an SUV and you got a fish tank at your house? Sweet, we got one. Okay. How about you got fish but no SUV? All right, 2 of those. And last is you don't have SUV or fish. Obviously, a complete social dropout. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. And if I add them all up, 15, 25 again. Good. That means I didn't miss anybody. Okay, now I'd like you to figure out these 3 answers. What's the probability of SUV? What's the probability of SUV or fish? And what's the probability of SUV and fish? Figure out those 3 probabilities for me. Have them on your iPad. And we're pretty much done with this lesson. That's all there really is to learn about it. Okay, here's what you should have had. SUV. SUV would be 8 out of 25. SUV or fish. SUV. Oh, wait a minute. Is there a mistake on the SUV? Why did I do 8? I subtracted them. That's really weird. I'm sorry. 10. Thank you for paying attention. Last you just believed me. That's not good. All right. 9 plus the 1 makes 10. 10 out of 25. The SUV or fish, or sounds like it's a small number, but it's actually the big one. This, and this. So it makes a total of 12 out of 25. And the last one was SUV and fish, and seems like it'd be a big one, but it's the opposite. It's actually the small one. And so it is only this one. So this one was 12 out of 25, and this last one is 1 out of 25. Raise your hand if you had those 3 right. If you didn't and you know what your mistake was, then we're all good. All right, that's the basics of Venn diagrams. And that's all I'm going to have for today's video.